Hello and welcome in to the second video, the examples video for lesson 6 for Precalculus 2. As you can see again from the timestamp, a longer video here, so you may want to watch some of it, and then when you're tired of working problems, come back, do it again, continue on. But these examples should cover all the different types of problems that you're going to encounter on your mastery sets, on your in-class assignments, things like that. So the first problem we're going to look at is a SOHCAHTOA problem. Now, there's different varieties or variations of how you'll be given these problems. You may be just given a triangle that's completely filled in, has all the sides, and says, okay, find all these different angles. You might be given a picture of a triangle that has one of the sides missing. So you have to do Pythagorean theorem and then calculate from there. And then I'm going to give you a version of what's on the final and therefore will be on your first exam. And so I just want you to see how it's worded and how you go about solving it. So it's straightforward, I should say. It's not easy, but it's straightforward once you understand what information you're given and how you're going to make that a SOHCAHTOA problem. So we have the following. In a right triangle, and there's our key words, right triangle must be a SOHCAHTOA problem. So triangle ABC with right angle at C and side B is equal to 3 and side C is equal to 5. We want to do the following. Find the missing side A and find sine of A, cosine of A, tangent of A, cosecant of A, secant of A, cotangent of A. Like, what is going on here? All right, so one thing, and I didn't mention this in the earlier videos, but when we have a triangle, now let me draw it down here. So if we're given some triangle, ABC, and in this specific problem, it told us that the right angle is at C. So I have to put that by the right angle. And I could put A up here and B down here, or I can put A down here, B up there. That doesn't really matter. But what does matter is that angle A is across from side A. Angle B is across from side B. And angle C is across from side C. So no matter where I put A and B is fine, but I have to make sure that I put side A and side B in the correct spot. Now it told me what? B is 3. So side B is 3, so down here. And it told me side C is 5, so that means the hypotenuse is 5. And the first thing I want, is side A. Well, side A is what? Well, we can either do Pythagorean theorem, or we notice this is what? Oh, 3 and 5. This must be a 3, 4, 5 triangle. So therefore, side A is 4. Let me stop there, let you kind of take it all in. We have this triangle, and so let me draw it this way in case this is how you drew it. Right angle, so C has to go there. If I put A up here and B down here, that's okay. But side C is across from C. Side B is across from B, and so side A is down here, which again, 3, 4, 5 triangle. So these guys switch depending where I put my angle, and it doesn't matter, and we're going to see that here in a second. Now, I want all the trig functions of what? Of angle A. So it's all based on this guy here or this guy here, depending which triangle I drew. And you might have drawn it this way, somebody else might have drawn it the first way. So let's use just the triangle on the left to start and see what we get for values, and then see if we get the same answer if we use the other triangle. Again, this has all been a right triangle, which is what? SOHCAHTOA. And so, hold on just a second. Okay. All right. So by SOHCAHTOA, sine is opposite. So from A, opposite is 4 over hypotenuse 5. Cosine of A, so using this angle here, adjacent over hypotenuse 3/5. Tangent, opposite over adjacent, 4 over 3. And then the rest of these are just what? The reciprocal, flip it. So 5 over 4, 5 over 3, 3 over 4. So those are the answers I get if I use the triangle on the left. What if I drew my triangle like the one on the right? Well, sine is what? Opposite over hypotenuse. Opposite is 4/5. Same answer. Cosine adjacent over hypotenuse, 3/5. Same answer. And you're going to get the same answer for all these as long as you drew your triangle correctly. So that is the type of problem you will need to know how to do for the exams to test the concept of SOHCAHTOA. Next problem, solve for x and round to 2 decimal places. I was going to do d dot p. We have a right triangle. Our measurement down here is 18 degrees, x, and 12. So I have a right triangle, must be able to do SOHCAHTOA. What pieces do I have? Well, from the angle, I have the adjacent and I have the hypotenuse. So by SOHCAHTOA, that means what? I'm going to be using cosine. So cosine of 18 is adjacent x over the hypotenuse 12. So multiply both sides by 12. Make sure your calculator is in what? Degree mode, because it's 18 degrees. And when you do this, you should get an answer of 11.41. And again, my suggestion, once I write these out, maybe try to give it a try, see if you can do them. If not, follow along, and then you'll have all those problems on the mastery set you can do. So solve for x. And in this situation, it does not say round your answer. So just like WebAssign, if it doesn't say round your answer, I don't want a decimal answer. So put away your calculator. You don't need it for this problem. Let's say our angle is 45. And we have x over here, 3 on the hypotenuse. So this is what? This is opposite and hypotenuse, which is sine. So therefore, sine of 45 is equal to x over 3. So multiply both sides by 3. So I get 3 times sine of 45, but he told me don't use my calculator. So what can I do? Well, we know the unit circle, right? Sine of 45 is root 2 over 2. So therefore, x is 3 times the square root of 2 over 2. So this is the kind of answer you would need to give on a test if it says solve for X and it doesn't say round your answer. If you do this on a calculator and then decide, I'll round it to 2 decimal places because George seems to like 2 decimal places, you're going to get it wrong. You'll get some partial credit because you kind of knew what you were doing, but then you didn't use your unit circle like you should have. So make sure if it doesn't say round your answer, I don't want a decimal answer. All right, now we're going to get into our word problems. So I know it's what everybody hates, but just take it step by step, fill in the information you know, and then hopefully you can work it from there. So if a 10-foot ladder is leaning against the wall and makes an angle of 53 degrees with the ground, how high is the ladder above the ground? And again, let's round to do decimal. So, okay, now he does want me to use my calculator. So draw a picture. Even if you're not Michelangelo and the greatest artist in the world, try to sketch a picture whenever we have these word problems. So we have what? We have a wall. We have the ground. We're assuming that the wall is perpendicular to the ground. And then we have this ladder that's leaning against it. And it tells us that the ladder is 10 feet long. So that's 10. It tells us that the angle it makes with the ground is 53 degrees. So our 53 goes there. And we're trying to figure out how high is this ladder above the ground. So we have what? We have opposite and hypotenuse. So that's sine. So sine of 53 is opposite x over hypotenuse 10. So multiply both sides by 10. And when you put this on your calculator that's in degree mode, rounded to 2 decimal places, you should get 7.99 feet. All right, next. So a plane is flying 1,200 feet above the ground. The pilot sees 2 cars on opposite sides. Angle of depression to one car is 37 degrees and 55 degrees to the other. How far apart are the cars? To the nearest foot. So this is what? This is our plane over the straight road kind of problem. They're on opposite sides. So it's this picture here. We know the height is 1,200. We know one angle of depression, which is the same as the angle of elevation up, is 37 and the other is 55. So this guy is X, this guy is Y, and we want to know the total distance that they're apart. So you are perfectly justified using tangent and finding X and using tangent and finding Y, or you can use the formula that I gave to you guys in the lesson video, which is what? D is equal to H over tangent of the small angle. And because they're on opposite sides, we're adding. So H over tangent of theta of the big angle. So go ahead and hit pause, try to work this, see if you get the right answer. Once we plug in these values, my height is 1200. My small angle is 37. Then 1200 tangent 55. And when you do all this on your calculator, you should get that the distance is 2,433 feet. All right, the next problem. Solve for X. Round to one decimal place. So we have this picture here. So this problem did not mention anything about a plane, a straight road, cars, mile markers, nothing. But this is what? This is an equivalent problem to that of a plane over the straight road. But it's what? Plane over a straight road, seeing two cars on the same side, how far apart are they? And so you can solve this. That's not a four, that's a terrible looking airplane. So here, there, a little better. So this is not a plane over the straight road word problem, but it's solved the exact same way. But because they're on the same side, it's going to be what? It's going to be a minus problem. So we have distance is h over tangent theta small minus h over tangent theta big. So the distance, which in this case is x, is the height 82 over tangent of 30 minus 82 over tangent of 60. And when you do this on your calculator, round to one decimal place, you should get 94.7. All right, next one. I know there's a lot here, but I promise it's worth it because this should help you on all your mastery sets. So find theta to the nearest degree. So theta is this skinny angle down here. This side is 3, that side is 8. And so in this case, we have what? From theta, I have the opposite and I have the adjacent. So that means I'm doing what? I'm doing tangent of theta is opposite 3 over adjacent 8. So if I do tangent inverse of both sides, I have tangent inverse of 3/8. And when I put that on my calculator, rounded to the nearest degree, I should get 21 degrees. Next problem, find the area of a triangle with sides 3 and 4 and included angle of 120 degrees and round to 1 decimal place. So we only have one formula for area of a triangle, and that's 1/2 AB sine of theta. So in this case, it's 1/2. A is 3, B is 4, included angle is 120. So when I put this all on my calculator in degree mode, because it's 120 degrees, you should get 5.2 as your answer. Next problem, find the exact value of sine of cosine inverse of 2/3. Aha, an inverse problem. I know this means right half, top half of the circle. Cosine is top half. Do the inside first. So where on the top half of the circle is cosine equal to 2/3? I have no idea. So how am I going to do this problem? Build a triangle. So we do what? We call this piece theta. So theta is equal to cosine inverse of 2/3. So cosine of theta is 2/3. Build my right triangle. Cosine is adjacent over hypotenuse. And so now, by my Pythagorean theorem, I have 2 squared plus, again, let's call this A. A squared is 3 squared. So 4 plus A squared is 9. A squared, so subtract 4 is equal to 5. Therefore, A is the square root of 5. So now rewrite the original. So I have sine of theta. That's what I'm trying to figure out here. Go to my triangle. Well, sine of theta is opposite over hypotenuse. So root 5 over 3. So that would be your answer for that one. The next problem. Whoops, let me slide that down. Write as an algebraic expression in X, and I have tangent sine inverse of X. So this is what? This is also a build a triangle. So theta is sine inverse of X. Take sine of both sides. So I get sine of theta is X, or let's call it X over 1. Draw my triangle. So sine is opposite over adjacent. And as we saw in the content video, this ends up being square root of 1 minus x squared. Rewrite the original. So I'm just trying to find tangent of theta, which is opposite over adjacent. So x over square root of 1 minus x squared. Do not rationalize these. When you have these right as an algebraic expression problems, Unless it specifically says it, do not try to rationalize it. All right, then the last problem I want to do, there wasn't really anything in the content video of it because it's kind of stuff we already know. It's just we're now going to use this idea of SOHCAHTOA and the inverse problem. So if you remember back to lesson number 2, you had a problem where it said find the trig values if tangent of t is -3/4 and cosine of t is greater than 0. So if you remember back to then, we had to do this how? We had to use our Pythagorean identities. And we had to then calculate secant. And then from that, I could take the inverse to get cosine, then do Pythagorean identity again to get sine, and then take reciprocal to get cosecant. There's a lot of calculations, a lot of fractions, a lot of radicals, things that could really get messy on us in a hurry. But now that we know SOHCAHTOA, and now that we know the inverse of triangles, we can do this in a much simpler way. It's also a build a triangle, but not those build the triangle problems like we just did in the last 2. We still have to figure out what quadrant we're in. And so tangent is negative, so that's negative where? Quadrant 2 and quadrant 4. And cosine is positive, which is quadrant 1 and quadrant 4, meaning this value of t is in quadrant 4. So what I am going to do now is, instead of using all those Pythagorean identities, I am going to draw a triangle that goes down into quadrant 4. I'm going to put t so that it touches the x-axis. Now, I'm going to use SOHCAHTOA to start figuring out these other sides. So tangent by SOHCAHTOA is what? Opposite over adjacent. So from t, opposite here is 3, adjacent is 4. But I have this negative here, and I have to figure out which of these numbers does it go on. Well, it's going to go what? On the 3, right? Because I'm trying to get to this point of the triangle here, so I have to go 4 units to the right, 3 units down. So it's not really like the length of the side is -3. The length of that side is 3, but the negative is telling me which direction. And so I have to put it on the 3 there to tell me that I'm going down. And so 2 things about this. T should touch the x-axis. And then the other thing is that our hypotenuse is always positive. So if this would have been sine or cosine, and I have a negative there, then I know the negative has to go with the side of the triangle because the hypotenuse is always positive. So this again is one of our famous 3, 4, 5 triangles. So the hypotenuse in this case is a 5. Now that I have this triangle drawn, I can figure out all the values. So we know tangent of t is -3/4. So therefore, cotangent of t is -4/3. And now I also don't really have to worry about, okay, do I have the signs correct or not? Because I'm going to be getting the sine off of the triangle. So sine is what? Opposite over hypotenuse, -3/5. Cosine is adjacent over hypotenuse, so 4/5. Cosecant, I have to flip sine, -5/3. Secant, flip cosine, +5/4. So you can see we're already done with that problem. I didn't really have to do a bunch of calculations with fractions and radicals and all that. All I had to do was draw a triangle into the quadrant where it goes, which we figured out is quadrant 4, and then put the sides on the appropriate triangle. And that's how you would do that one. So again, I know it was a little bit longer of a video with all the examples, but that should get you through all the problems you need to do in the mastery set. So we'll see you guys in class, and we'll see you guys on video number 7, lesson number 7.